Good afternoon and welcome to our webinar. My name is Joseph Eiger and I'm an application engineer here at Concepts in Production. We are located in Amory, Mississippi. And in today's webinar, we're going to talk about our Markforged 3D printers, the different grades, and depending on whatever purpose you have for it, there's a solution that Markforged can provide for you. So just as a brief introduction about our Markforged printers, they were founded in 2013 at MIT. They shipped their first printer 2014. They had a 300% growth, achieved profitability in 2017, in the first quarter. As far as the range of materials that Markforged can provide, it depends on what you're trying to achieve. For example, if you're looking to print functional prototypes, you can print with plain plastic material. There's two base materials that Markforged can print with, either nylon or onyx material in this first model over here. If you're looking to build some end-use tooling and fixtures, we're going to talk about an example. One of our customers achieved great success in building fixtures from Markforged industrial grade printer. So you can print the same base material, nylon or plastic, but it's a material that you can reinforce with 4 different kinds of fiber: carbon fiber, fiberglass, Kevlar, and high strength, high temperature fiberglass. Most of all, Markforged can provide a metal X printer that's capable of printing metal parts. It's as strong as casted metals. It's something that you can machine and do all the applications that you can do with regular casted metals. Moving on to a range of reinforcement materials that I mentioned earlier. I mentioned that we can print with nylon and onyx. So the first part here is plain nylon. This is a Ducati brake handle. It doesn't have any reinforcement in it. That's just for basic printing. The second one here is printed with nylon with continuous fiberglass. If you're looking to reinforce your part where cost is an issue, like you're looking to reinforce your part with the cheapest fiber available, you can just use fiberglass. Now, if you're looking to reinforce your part with an abrasive resistant material, you can choose Kevlar. Keep in mind all the properties that Kevlar has to offer when it comes to fire resistance and abrasion resistance. I remember we had a customer that had a wire EDM. He had a really bad abrasion problem with that wire holder, so he came to us. We reverse engineered that part for him. We printed it with nylon. We reinforced it with Kevlar. What he had to replace 4 times a year, doesn't have to do that anymore. He's still running that part until today. Now, if you're looking to reinforce your part, where cost isn't really an issue, but weight is something to be considered. So we reinforce our material or our printed part with carbon fiber. It's among these 4 fibers is the most expensive fiber, but it provides really lightweight properties while providing a strong part. And the second base material is the onyx. Onyx is like nylon. You can print it without any reinforcement, but it provides a beautiful surface finish that you can get up to, that surface finish can get down to 50 microns in resolution and when it comes to finish. Now let's take a look at these stress strain plots here. So in this plot, it shows the chopped carbon fiber reinforcement here. It compares onyx to ABS to nylon, and you guys can see how strong is the onyx compared to ABS and nylon. Like we know, or we're well aware how widely available ABS is. I'm aware that there's tons of 3D printers that can print with ABS, but at the same time, you're not printing something that's durable. ABS, we know how that problems associated with ABS. If you probably put that part in the sun or in water or whatever, you're trying to deal with it. And if we look at this stress strain curve on the right side here, we're looking at continuous fiber reinforcement, and we can show here the carbon fiber compared to 6061 D6 aluminum. So you guys saw that brake handle, that Ducati brake handle in the previous slide that was reinforced with carbon fiber. That handle can be used on the bike, like a normal part, without any issues. And I remember presenting a chain link on one of the slides. We don't have it here, but just a little fun story. They printed a chain link at Markforged, and they tested it. It was able to withstand 22,000 pounds in weight. That's like 3 Ford F-150 trucks. That was a chain link that was reinforced with carbon fiber, so it's pretty impressive. And again, we see the fiberglass around the 240 megapascals in range, and the onyx and nylon here, which is not reinforced. So how does this Markforged printer, why is it able to print such strong materials? So you guys are probably aware that there's tons of printers or tons of printing solutions out there. Their reinforcement that they can provide is chopped fibers in them. I wouldn't recommend printing with or maintaining a chopped carbon fiber part as your go-to solution, because it will never be as strong as the continuous refilament technology printed part. So the way this Markforged printer, this is the print head, shown on the left, it prints with fiber and the nylon or onyx at the same time. It's like a sewing machine, so they print at the same time. It lays the nylon material, as you guys can see here, this kind of transparent material down there, and there's the continuous fiber that it lays on top of it. So they call this technology, continuous fiber filament technology. And when it comes to the print bed itself, as you guys can see, this is the holder of the bed. The kinematic coupling is accurate within 10 microns. Each time you take the bed off and you put it back on, it's you don't have to level that bed anymore. All you need to do is just level that bed one time, and it's gonna be good for several prints, because it's gonna reposition itself. Like once it sits in these 3 holes over here, which we call the kinematic coupling, it's kind of like magnet. It's gonna sit there within 10 microns repeatability. Other applications for reinforced nylon, or I keep mentioning nylon, guys, but we're gonna get to the onyx, but I just wanted to point out to you that you have 2 types of materials when it comes to base material: nylon, which is this transparent material, and onyx, which is the other plastic, but it's the one that provides you with the sheen finish. You can embed electronics your printed part. As you guys can see, you can start your print, let your printer work for about 5 or 10 layers. You can pause the print, put the electronic insert in it, and you can resume the print, like this example shown in this left picture. Another application for it is you can add inserts to your print parts, like this, like shown in this picture here on the right. So I'm pretty sure lots of other printing solutions don't offer this this advantage that you guys can see here on this slide. Another thing, The main concern in every business is cost, and the cost associated with producing a part. You always want to make a product, give it to your customers. At the same time, while saving on cost, you don't want to give cheap material. A lot of people think that, hey, if I'm achieving a good result at a lesser price, that quality is questionable. Not at all. An example given here is this weld fixture. If you use the conventional method, which is machining, the lead time, first of all, is going to be 3 to 4 weeks, and the cost associated with that is about $1,500 per fixture. With Markforged, with 3D printing, you can achieve a fixture as strong as the one you get in conventional methods. The lead time is 2 to 3 days in printing time, and the cost associated with it is $300 per fixture. So you're not sacrificing performance over price, not at all. We got 80% in saving in this scenario over here. Another example I can give you guys here is the weight reduction. So if you are trying to print a tool or a wrench like the one shown, like the plain wrench shown in the background here, you can achieve the same result, the same strength, reinforcing that part, like the one reinforced with Kevlar. Kevlar is the yellow fiber. So the first part weighed 42.75 grams. The second part weighed half of that, but achieved the same strength. With Markforged printers, you can print any tool you need. And we're going to see the software, how easy, how user-friendly the software that drives the Markforged printers is to use. And pretty much design your material, throw in the software, make the necessary changes, whether it's fiber or layers or the fill density, you name it, and you just hit print. This example shown, like, think about how much would it cost you and how much time would it take a manufacturer to produce a part like this for you, just to bend copper tubes like the one like this example given here. So we covered maybe the prototype portion of the Markforged printers. Now let's talk about the Mark II, which is the industrial grade, and the reliability that this Mark II printer has to offer. Well, it supports all of the Markforged materials. The onyx as a plastic material, and it reinforces with the 4 fibers that I mentioned to you guys. The build plate, the size of the build plate is about 13 inches by 5 by 6 inches in the Z direction, which is a decent size for a build plate, unless if you're planning to build a part that's bigger than that, you can split that part in 2 portions, like one of our customers is doing. The surface finish, or the layer resolution, is 100 microns, and the type of applications that you can use those products out of this printer, you can use in automotive, in aerospace, in prototyping, in custom manufacturing. And just to note something here, guys, that it's got a heat deflection rating of 245 degree Fahrenheit. Now I don't mean like get that amount of heat and put it on the part itself and burn that part with it. No, it's like heat deflection. For example, if you print a part and to be used in the engine compartment, it can withstand that kind of heat generated under the hood, and you're gonna end up with stiff reinforced parts in hours versus weeks, if you choose the conventional method, which is machining. Now let's talk about the Mark X. Mark II, this printer here is the desktop series, and we're gonna see a chart later on down the slide that compares the different grades and the different prices maybe for those printers, and what they can do and what they can't do, and the difference in capabilities between those printers. So the Mark X prints large parts. Print area wise, or the print bed, it's about double that of the desktop series, but the volume is more than 2.5 times of the Mark II, this region, the build plate. And depending on what Mark X grade you buy, because there's X3, X5, and X7, you can reinforce it with all of the fibers that you can use in the Mark II. And on top of that, the X series provides the quality control aspect. And what that means is it provides the laser inspection, which means while you're printing your part, you're still in the early stages, maybe layer 1 or layer 2, you can pause the print, and using the software you can inspect the part to see if it's up to spec, maybe tolerance wise, maybe if you need to change something, using that incredible laser inspection capability in this Mark X printer. If everything checks out, you can just proceed with your print. If not, you can do whatever changes that you need to make to your part. Besides that, there's auto leveling for the bed, or again using the laser technology, and it provides new precision build features. When it comes to resolution, I know I mentioned to you guys that the Mark II can print with 100 micron resolution. The Mark X can print up to 50 micron in layer height or layer resolution, thus providing that sheen finish like this part shown inside the printer. And besides that, guys, in all of these printers, whether it's the desktop series or the industrial series, every time you're printing a part, you don't have to be sitting next to it until the part is done, especially in this Mark X, because in the Mark X there's a built-in camera inside the printer. It doesn't matter where you are, you can just, while this printer is working, you can just log into the software and take a look at the pictures, because this printer takes a picture of the part in progress every 5 layers, and see if everything is working fine. Basically, you can run it overnight and watch its progress anywhere you are. Now, let's take a look at this full range of printers. So we have this desktop series, shown in blue, and the composite series shown in orange, and we have this awesome metal printer at the very end. So in the desktop series, printing composites, again, whether you're trying to print for prototypes or for maybe even fixtures, and for whatever application you're trying to achieve. There's the Onyx One. The price of it is around $3,500. It prints just plain onyx. Okay, so you can't use any fibers with it. There's the Onyx Pro, which is about $7,000. You can print with onyx, or you can print with onyx as a base material, but you can reinforce. You can use fiberglass as a reinforcement material. And later there's the Mark II printer. It's about $14,000 or $13,500. You can print with onyx as a base material and all of the 4 fibers as a reinforcement material. Moving on to the composite, to the industrial grade printers. When it comes to composites, again, there's the X3 series, which is about $37,000. You can print with onyx while taking advantage of the inspection, of the quality control, of the auto leveling, of the bigger build size, all of the advantages that I mentioned in previous slides. X5, again, same as X3, but you can use the fiberglass as reinforcement, and X7, which you can use all of the 4 fibers with it, using that printer with its full capability, all of the 4 fibers and everything that the X series printer has to offer. And the Metal X is the latest Markforged release. It's a printer that can print metal parts or that are as strong as the casted metal parts. The price of it is around 100 grand, and we're gonna cover the details of this Metal X in a bit. Now this chart says how you can upgrade your printers. Like if you buy an Onyx 1, if you upgrade to Onyx Pro, installation comes with the upgrade, and of course you can take advantage of more materials to or more applications, because you can reinforce your material. And if you want to upgrade to the Mark II, you can reinforce with continuous carbon fiber and all of the fibers versus just fiberglass like the Onyx Pro. And again, upgrade includes installation. Now the Mark X printer, let's take a look at this nice looking or sheen looking drone. The build volume of it is about 13 inches in the X direction, about 10 inches in the Y, and about 8 inches in the Z direction. And again, this is the X series, whether it's X3, X5, or X7. Regardless of what reinforcement you can use in those parts. Moving on to the Metal X, again, this is the latest release from Markforged. The parts that you can print, it's equivalent to the casted parts when it comes to withstanding high temperatures, when it comes to the hardness of that part, or the isotropic strength, which when it comes to fatigue and straining that part, so on and so forth. How does metal printing technology works with Markforged? They use a technology called ADAM, or Atomic Diffusion Additive Manufacturing. You start with your design. You save that part as an STL file. You send it to the printer. That printer will use a metal powder that's bound in plastic. This is what we call the green part at this stage. And then you take out that part and you put it in a washing station. It will allow that machine to remove some of the binder material. And then you send it to a furnace that settles that binder together, thus giving that part its strength. So washing it, then putting it in the oven so that the metal powder can fuse into solid metal, and you'll end up with a part that's up to 99.7% dense, which is a pure metal part, and it's ready for use, can be processed and treated like any other metal parts. When it comes to precision, you don't need any post-processing. As you can see, this is a joint, a ball joint part. We have it in a plastic version, in a reinforced version, and this is the metal version. And as you guys can see, the threads here, it's with such high precision that you don't need any post-processing. So the full package for the Metal X printer, you start with the Metal X, the printer itself, which is about 100 grand, and the washing station, which is about 10 grand. It's basically a machine that you put an acetone-like liquid in it. Right out when you take the part out of the printer, you put the part in it to remove that unnecessary binding material and plastic and all that. And once you take that part out of the washing machine, you put it in the oven, or what we call the sintering machine. Now, depending on the size of the parts that you print, you can choose between the smaller sintering machine, which is about 15 grand, and the larger sintering machine, which is about 50 grand. Let's talk about the software that drives the printers. It's called Eiger. It slices, stores, and organizes all of your parts that you want to 3D print. And within this user-friendly software, you can control the fiber orientation, whether you want to use isotropic, reinforcement, and you can control the volume of that fiber. And based on how you tinker with the part, you know, how much you want to add fiber, what's the fill density, and what kind of finish you want to achieve at the for your part, it gives you updates in real time how much that part is going to cost you and how much that part is going to take to finish. And you have cloud or local storage option when it comes to storing those 3D printed parts, those files for the 3D printed parts. And of course you have the on-premise option. This is a quick a presentation for the software. As you can see, you go from the software itself to the inner structure of the part. Right now we're tinkering with the fiber density, or the moment we switch between 2D and 3D is when we control whether we're seeing the part from the outside or the inside. And as you guys can see, we choose the part. This is on the build plate, and as you guys can see on the left, there's the time and the price associated with it. Go to the 2D view. You can see layer by layer the structure of the part on the inside, and based on that you can make your decision where to add fiber, where to remove, where is it necessary to reinforce, so on and so forth. So it's pretty user friendly, pretty easy to use, and it helps you more efficient based on the time and the price that the software can provide you with all that information. I'd like to share with you guys a customer success story. It's our customer, the company's name is Daco. They have multiple locations, but our customer, this particular customer, is located in Arkansas. So they build tensioners, belts, pumps, vacuum systems for automotive. So basically, here's some of the advantages that our customer experienced ever since they bought the X7 printer. Their main concern, or their main goal, was to print fixtures for manufacturing purposes. All right, so to mount pipes and models on them. So previously, when they relied on machining for fixturing, this example in the picture on the left shows that the Markforged printed part, each fixture had been costing them $5 to $10, and versus the machined, the competing 3D printed solution from a different printer used to cost them about $400. And on the picture on the right, it's a fixture that they use to clamp on the hoses, so and the pumps as well, so they can clamp the hoses and components to it. And that's another example of the fixtures that they print. And my main goal here, guys, from this slide is to show you how challenging geometry, when it comes to all of these curves and angles that this fixture has, that you can achieve with the Markforged printer. Here's a clearer picture. This fixture on the left side, it was quoted to them at $6,500, versus they printed it with Markforged. Of course, in two different portions. It cost them $50, and it took them only 2 days to build. And as you guys can see, they clamped their hose on that fixture. Another example for fixturing, is shown in Onyx. That's something that they previously made using machined aluminum. That's just part of what they do, or part of what they were able to achieve Markforged printer, because when we went there on site, there was like a tremendous amount of applications that they were incredibly happy about, and the number one reason for their success, that's stated by our customer himself, is within 6 months that printer was able to pay for itself. And we're talking here, it was able to pay for itself because of all the savings that that printer was able to provide them with versus the conventional machined methods. So that was it for our webinar today, guys. I'd like to thank you for attending today's webinar, and you have a great day.